Welcome back, guys, to the final part of my lecture series. And in this topic, we will talk about distribution system reliability. And reliability is a topic that is closely related to me, and I am very passionate about, which also forms the core of the focus for my research. So, if any one of you who is ever interested to pursue your study further and you want to do your research on power system reliability, feel free to contact me and we can discuss the details. So, since this is a topic of my passion, I will give you some insight on what power system reliability entails, and you will get an idea of what power system reliability is about. Okay. And okay, let's begin by some definitions of reliability, adequacy, and also risk analysis over here. So reliability is described as the security of the systems and the avoidance of power outages. If you are strictly relating reliability to power systems, but in general, reliability is the ability of a particular system to perform its intended task for a particular intended period of time. And adequacy is having the sufficient system capacity to supply the electric energy requirements of the customers. So it is related to having sufficient supply, sufficient input, okay, to match a certain output. And risk analysis, you can read this sentence yourself, but risk analysis is as simple as the multiplications of an event occurring, and that event has an impact that can be measured, multiply with the probability of that particular event from happening. So we talk about risk all the time. So now with this risk, we define it formally. And next time when you want to quantify risk, then you need to know what is the measurable impact of the event, and you need to know what is the probability of the event occurring. So by multiplying these two things together, then you get risk, right? So this is a typical graph that all reliability analysts look at. So as you improve the system reliability, right, from 0 to 100%, you notice that investment costs into that system will increase, as given to you by this curve. And this makes sense, right? Because as we improve the system by having more investment into it, then the reliability of the system will increase. Or else we will not do it, isn't it? So another one that you can look at is this thing, the cost of interruptions, right? The cost of interruption. So the cost of interruptions will actually drop as you increase the reliability of the system. So if I decrease the reliability of the system, then the cost will increase. That makes sense, right? So if you have a particular system or your computer, for example, is less reliable, it breaks down very often, then that computer costs you more compared to a computer that does not break down as often. So we need to balance costs and reliability all the time as a reliability engineer. And the middle point, so we have to find the optimal point of it. Optimal point is the point that we often want to find that strike the balance between reliability and cost. So we are neither focusing too much on reliability or cost. So there's another interesting concept called the bathtub curve that reliability analysis always rely on. So this bathtub curve is also known as the hazard function. So in reliability analysis, when we talk about risk, we sometimes also replace the word risk with hazard. So risk and hazard, they are interchangeable. Okay, and the curve illustrates that the failure rate is a function of time. So when we talk about bathtub curve, and then there is a concept called failure rate that arises. So for any event, for any component, right, they will fail at one time. Okay, at one time, components will break down. How fast this happen is controlled by the failure rate of the component. For example, your computer can break down in once every year, so the failure rate will be 1 per year. If a computer breakdowns in once every 2 years, then the failure rate of a computer is 0.5 per year. So with bathtub curve, so but through our observation, right? Through our observations, we notice that the lifetime of any component, generally speaking,